Today we're going to talk about empirical formulas. What's an empirical formula? It's the most basic formula you can have without repeating it to be a molecular formula. To solve these problems, we need a couple of tools. First, you need a periodic table. Second, you need a calculator. What types of problems are there? There's two basic types. There's one where they give you the percentage of the components. The other one, they give you the total amount of the compound and individual amounts of each component. In either case, this is the way you should be solving it. First one is convert the information to percentage. Second, assume 100 grams total and each percentage is part of 100. 100 grams total and each percentage of the components. Find the number of moles of each component. Then multiply or divide by a number that provides a whole number ratio for the compound. It's almost easier to show you a problem so you can see what I mean. So let's talk about the first problem. Problem is, what is the empirical formula of a compound which consists of 89.14% gold and 10.80% oxygen? Some cases you will get a problem where they say 89.14% gold and the rest is oxygen. What you need to do when that happens is subtract this number from 100 and then you will get this number. Okay, so let's look at the information and let's try to follow our steps. Step one, the info is already in percentage so we don't have to do anything. Step two, we assume 100 grams of material, which equals 100%. Step three, you convert 2 moles each component. We have two components, gold and oxygen. In this case, we have 89.14 grams of gold. We convert it to moles, which is 1 mole over the atomic weight. The atomic weight you get from the periodic table. And you get 0.45 moles. Do the same thing for oxygen. Use 16. The reason you don't use 32, it's in a compound, so you're only worrying about the monatomic value of oxygen. You do that, you get 0.670 moles. So that's step three. Now we got to get something like an LCD. What's a way to get the lowest number in here? So you divide everything by the lowest number. Gold is 1. Oxygen is 1.5. But you and I both know that you can't have a compound that has anything but whole numbers. So this is really gold, 1.5 oxygen. That is not acceptable. So you have to multiply it by a whole number that gets you to a whole number. In this case, 2, because you know 2 times this is 3, 2 times this is 2, this is gold, and this is oxygen, so the compound is Au2O3. Okay, that's one type of problem. The second type of problem is where they give you the information, total information in grams, and then they give you individual components. So this problem is 170 gram sample of an unidentified compound contains 29.84 grams of sodium, 67.49 grams of chromium, and 72.67 grams of oxygen. Find its empirical formula. Even though the problem doesn't say it, you know this plus this plus this equals 170 because they're all the components and they only have 3. So the first step now is we have to convert everything to percentage, which means you take the number of grams of the material over the total weight of the material times 100. You do that for each component. Again, these are the numbers that we pulled directly from the problem, times 100, and we get percentage, which has now got us to this point right here. Next point, we assume 100 grams. Step 2 is very simple. This becomes 100 grams. Okay, now step 3, find the number of moles of each component. Again, we take this number, 17.55, convert it to a mole number. In this case, we know 1 mole of sodium is equal to 22.99. Where do we get that? Periodic table. We repeat that for each one of these components. This information is all obtained from the periodic table. Now we have our ratios. Obviously, we have to divide everything by the smallest number, which takes us to step 4. Step 4 is sodium is 1, 1. Oxygen is 3.51. Okay, same problem. We got to multiply it by a whole number that gets us to a whole number. In this case, it's 2. Now we end up as Na2Cr2O7. That's the answer. Now, whenever you're doing these problems, sometimes these ratios won't come out as clean. They may come out 1.25, 1.75. Same thing applies. You multiply it by a number that gives you a whole number. This will give you 5, and this will give you 6. Sorry, 8. Scrap it.